Yeah. So I want to now let me share the whiteboard, because I want us to do an example. Or before I can do that, let me first remind you about the 6 processes that one need to follow when um, uh, conducting an experiment. So let me share that first before we can go to an example. The processes that one should follow when we won't take a lot of time concerning this one, because the next chapter it will be about what the 6 processes. From chapter 2 onwards, we'll be applying the 6 processes. Here I just want you to get a taste on how to conduct an experiment. So let me go to remind you about the 6 processes. Here are the 6 processes. We said the first one, you plan. You plan, not forgetting that the definition of experimental design is that, let me remind you also of this one. Is that definition? Let's check this one. The definition of an experiment. We said a study in which the conditions are deliberately assigned by a researcher to individuals, objects, time slots for a purpose of seeing the effect, you see? Or we can check the first one. The experiments are performed to investigate, by investigators, you see? Experiments are performed by investigators in all fields of inquiry to discover something about a particular process or a system. So that's what we want to do now. Based on the example that I gave you last week, I said if you want to conduct an experiment, you will need these 6 processes. I said the first one is to plan. The second one, you design. You perform. You analyze that data. You confirm the result. And then you give some suggestions. So now here is the example that I gave last week. No, on Wednesday. Is it Wednesday? About the teaching methods. I want us to use that example to come up with the first 4 steps. I want us to use that example to come up with the first step. Can someone tell me how will you do the first one? How will you plan? What is the planning part based on my statement concerning the 3 methods? Let's plan. We're talking about planning now. Let's talk about the planning part. Can someone give me an example? Or it's fine because we have only 45 minutes. I said currently we can decide to do an experiment to compare the 3 methods of teaching to check which one is more helpful for the student, or to check if is there any difference between the 3 methods. So the idea of trying to come up with an experiment is what? That is the planning stage. That is the planning part. We want to check if the 3 methods of teaching, they are able to help the students, or which one is more effective than the other. By doing that, we're doing what? We're doing what? We are planning to check the effectiveness of what? Of these 3 methods. That is the planning stage. You didn't do anything so far. So now, how do you design? How do you uh, um, um, uh, check these methods. So that's where now I want to go to the whiteboard. Yes, Penny.
Oh, I was
Penny?
repeat what you just said on number 1.
Yes. Penny, I didn't get it. You're saying?
Can you hear me now?
Yes, I can hear you, Penny.
Oh, I was saying, can you please repeat what you just said on number 1 on the planning,
Oh,
on the
I
plan
was
base?
saying,
Yes.
um, you remember the example that I gave on Wednesday concerning the three methods of teaching: the venue-based, the online teaching, the one that we're applying now, and the video watching one, where we just give students videos, they go and watch, but when they write an assessment, they write what? The same assessments as the other two groups. So now, suppose we want to conduct an experiment. What we'll do, now we have an idea that we want to compare the three methods. So by doing that, having that idea that let's try to do an experiment about checking which method is more effective than the other. By doing that, what is the planning part. So how do you design an experiment to be able to check these three methods? That's where now I want to go to the whiteboard. Um, but whatever I'm explaining now is related to the next chapter that we'll be covering next week. So I want to show you how the two are connected. So we have planned. I want to go to whiteboard first. You have planned, and then the second one is to do what? The second one we agreed that is to design. How do you design? Designing now, it will come. How do you want to design this experiment? Um, please, let's behave. Don't write on the board. It's my turn now. If people are writing when it becomes bad. So we cannot just wake up in the morning for people to come and act like the way someone is doing. Please, guys, we're adults. So we have the three methods. Um, Pala, I'm not sure if is a new hand or it's an old hand. I noticed your hand is still up.
It's an old one.
Okay. We have three methods. Let's name them ABC, or venue-based, venue-based, online, and what is the other one? Video teaching. So what we do, we have these three methods, isn't it? We want to check the effectiveness of these three methods. We have how many students? We have 50 students, 150 students, and we agree that this is what? These are our what? The students is our what? We agree that these are our experimental units, where these methods, we're going to apply this method to what? To these 150 students. So I indicated that the problem with regression, applied linear regression, was what? The experiments are not controlled. So the question now that let's try to control this methods. How are we going to do it? We we have 150. So we want 50 to go to the first method, 50 go to the other 50 go to the online one, the other 50 go to the third one. So how do we assign these students to all these three methods? 150 from each and every method. How do we do it? there's what we call what? To avoid biasness, there's what we call what? Randomization. Randomization. Randomization, you'll complete the thing there. Randomization, why are we doing randomization? Is to avoid biasness. And again, let's say we have your class rep, Pumullo. She was selected to go to do the first method. Maybe she's part of the stand who's supposed to be assigned to this method. When we select a name, it falls under video, venue based. If we applied randomization, there's no way that she can complain that the way my name was selected, it was not fair. Why? Because randomization was applied. For example, let's go back to, I assume everyone knows about Lotto, right? Those Lotto numbers. The one that I still remember is the one where you have that jar with 49 balls. And then from that jar, they must get how many? They must get 6 balls from that jar. What they will do, they will shuffle the balls, right? And then that machine will pick a ball. There's no way that you can say, from my ticket, there's 13, but that thing machine, it selected 12. But your 13 was part of what? Of the 49 balls. So there's no way that you can complain that there was no fairness when selecting those balls, because all the 49 balls are what? Are involved. Do you see it? So even here, what we can do what the same thing with what the Lotto guys are doing. We can put all your names inside the jar, and then we start selecting. So what we can do is that we can create 2 jars. We can create 2 jars like this one. The first jar can have the names, and the second jar can have what? The methods. Let me show you. From there, I'll go to the notation. So what we are doing, we're applying step number 2. We want to assign. So what we do, you'll have the first jar. This one is with the methods, the 3 methods, which it means you'll have how many methods? 3 methods, but venue-based method, it will be repeated how many times in this jar? 50 times. Now you come to the other one, which is the other method, which is online teaching. It will be repeated how many times? 50 times. And again, this one goes with red. And now the last one, which is sorry, the last one, which is video watching, this one, it will also be what? In this jar, repeated how many times? 50 times. Now we have the second jar now with what? With the names of 150 students. The names of 150 students. So what we do, we want to select these names and the method. So what you'll do, you come to this jar, you apply the Lotto method, you shuffle here, you come up with the name. Let's say the name is Pumulo, it's Clean. Clean, now we have the name Clean. So how do we know that? How do we know where are we supposed to put the name for Clean to for which method. So it means we must go to the other jar and what? And do the shuffling again. If we come up with the red color, it means Tayani will be assigned to what? To video. Will be assigned to what? To online. We go back to the jar, we repeat the same what? The same process and what? Come up with what? Name Manyama. After selecting the name Manyama, we have to go to the other jar of the methods and check where are we supposed to assign Manyama, to which method. If we happen to come up with the blue color, it means Manyama will be assigned to what? To the venue-based method. Do you get what I'm trying to explain, guys? How do we assign the students to these three methods so that at the end they don't complain why I was assigned to video, not online? Do you get it?
Yeah.
Simon, I don't understand, to be honest. Can you repeat?
Uh, me too. Me too, sir.
Sorry.
I don't get it. I don't
Anyone
understand it.
who is following? Yes, Matitela. Matitela?
No, it's a mistake, sir.
Oh, it's fine. It's fine, Manish. It's fine. Let me repeat. Yes, Manga.
Okay, so if I'm not mistaken, you talked about shuffling. So we have the 150 student. How are we going to split them into 50/50s, and which group of 50 student will be assigned to a specific method? So according to what you have explained, you were showing the example by using the names of the
Yes.
student, assigning them to a particular method. So what you said you're going to, under the, for example, under the venue based, you're going to divide this 150, like you're going to do them as jars, then you're going to shuffle. If the name Manyama comes out, you're going to place it on the venue base. Then you're going to shuffle the jar again. If the another name comes out and is on the certain method, not venue based, maybe video viewing, that name you're going to assign it there. I don't know if I'm mistaken.
Yes,
That it
yes, you
doesn't
are right. But
avoid.
yes, let me explain. What we are doing, guys, let me start with the names. Or let's start. It doesn't matter where you start. You can start from the method, from there you go to the names. So let's pay attention. We want to select the method there. We go to the jar return methods, we shuffle. Suppose that when we pick what? We pick is it purple? A purple color. Purple color goes with what? A purple color, I said it goes with video watching. You are given the video and you go and watch. From there you'll be given an assessment. So now on our hand we have what? Suppose now on your left hand now you have what? You have the video watching. Now what you want to know, which student will be assigned to what? To this video watching. You have to go to the other jars where you have is full of what? It's full of names. You shuffle. After shuffling, the name that you come up with, remember already you have what? The video watching method. The name that is going to come out from the jar will go to what? To the video watching method. You'll assign the name of that student to what? To this jar. Now, you go back to the method again. You select another method. If it happens that is the what? Is the online method. You will go to the jar, you check, you shuffle, you select a name which will be assigned to what? To the online method. So you will do the what? The experiment. You will repeat the process until you are done with what? Selecting the 150 students. As I've said, these things is the thing that will be applying to what? To the next chapter. Whatever we'll be doing on the next chapter is exactly what I was trying to explain here. But due to time, remember we have only 45 minutes to cover everything. So there's someone, class rep, Manyama, are you here? Mr. Nkadimeng? Nkadimeng?
Sir. Yes, sir.
Yes.
The I mean the blue jar elements are equal to the purple jar elements.
Yes, remember we have 150, right? So the
Okay.
blue ones you will have 150 blue, 50 blue dots. You'll have 50 red dots. You'll have 50 what? 50 purple dots. Maybe it's my notation here. Maybe I was supposed to put blue when assigning here. Maybe I was supposed to put blue when assigning here. So it's because of the colors, and I don't have that thing to write today. That's why maybe it's causing all this confusion. But it's not a big deal. Tuesday, I can come back to this example and explain. And explain again the very same example. I can come back to Mr. Manyama or Pumulo. Pumulo. Pumul. Tayan.
She's not here, sir. She's trying to connect.
And then Manyama. Manyama. It's also not here. Guys, from the student side, can someone call a member who's not someone who's not behaving? Is writing on the board. So can someone from your group, guys, call the member to order? Maybe if the person hears from for fellow students, he will do the right thing. Can you help me, guys? You can open your mic and say something to the member who's misbehaving.
Yo, guys, please stop misbehaving. We want to focus and finish up with the class. Thank you.
I know maybe you are my guy or you're my sister or you're my brother. If you are not serious about this one, you can just go to sleep. We wanna learn here, please. Thank you.
Thank you, guys.
Honorable members, let's try to focus, honorable members. Let's try by all means. Let's behave. Let's listen to Mr. Happy Mashia, to Honorable Happy Mashia.
Thank you, leaders, for your help. I assume even the leader,
Sir, can you unmute yourself?
Thank you, my brother. What I was trying to thank you for helping me to call the member to the leader to order. What I was trying to apply now is the three methods. These three principles of experimental design. Now, these are the principles. I spoke about what? I spoke about randomization. Randomization is where we're doing what? The shuffling part. When we want to select the names of the student, we start by doing what? By shuffling. Now, replication. Remember, you shuffle the first time, you assigned the what? The students to those methods. Now you repeated the what? The process again. You repeat the process until what? Until you are done with the methods and the names. You'll be doing what? You'll be doing replication. You are repeating what? The process. That's what we call what? Replication. The last one now is what? Is blocking. Blocking is another chapter. Now, blocking, what we mean by blocking is that you bring in another factor that you think is having what? Is having an impact in what? In the outcome of your experiment. That is the blocking. So blocking on its own is another chapter. When you go to chapter 2 next week, we'll be dealing with the first two, which is randomization and replication. So next week, the two will be applied. The two will be applied. So when we apply these two methods, this is what's going to happen. We'll apply those two using what? Using an ANOVA table. So I decided to add this information here, that in the next chapter, we'll introduce the analysis of variance. We agreed that we'll be dealing with the ANOVA, which is an extension of what? Where you are testing two means from SSTA032. You tested the difference between two means there. Mr. Lemo is here. He taught you those stuff. There's no way that we can lie that we didn't do the stuff from first year. You did that part where you're comparing the differences between two means. So when coming to the ANOVA table, it's a technique where you compare two or more population means. In particular, testing the null hypothesis that the means are what? Are the same. This is an extension of the problem of testing the hypothesis about the means of two populations discussed from SSTS012 class. When the null hypothesis of no difference among the means is rejected, the next step is to check which means are not the same. So if you conclude that the three methods of teaching are not the same, so we want to know now, you must prove us which ones are different. So that's where you go to what? Multiple comparison methods. I think those who did first year taught by Mr. Chavalala, mainstream, he taught you about the LSD method. The LSD method, the taking method. So those things now they're coming back again. So with the remaining 10 minutes, I said we have to meet and talk about the notation. The notation that will be applied in this chapter is different from the methods that the ones that we've been using before. So let me give you a test from there. We call it a day. So whatever we did today, I will repeat them again, leaders, on when? On Tuesday. Oh, sorry. Mr. Ngadimeng, Mashud, is it an old end or is it a new end?
Old hand.
Thank you. So, yes, well, the first notation is the sum. Sum. How do we the summation? The summation in this the notation will be, this is the summation. Suppose we are dealing with chapter 2. When you sum something, you'll see the dots. When you see the dots, y followed by dots, only the dots, it means it's the summation of everything that will be given in the data set. For example, let's say we have A, B, C. We have this data set here. We have 2, 4, 9, 3, 2, 1, 6, 4, 7. Guys, suppose we want to find the summation of all these numbers. So the summation will be represented by y dot dot. So if you want to find the summation of everything which is given here, you write what? Y. So if you are given y dot dot, sorry, it means let me remove this so that I don't want to confuse you guys. So when you add all the information that is in the table, you'll have what? Can someone add the information from the table? From B, I can see 6 there. From the first column is 15, 21. So I can 38. So when you want to write it 38, when you say y dot dot, when you're given y dot dot, and with this is the sum of everything. So, but there's this one, y. So remember, I goes with what? The first dot is for the rows. The second dot is for what? Is for the columns. The columns. The columns. The first dot is for the rows. The second dot is for the columns. So now, when you check your data set, it's captured column wise, right? A is going down, B is going down, C is going down. So if you want to find, remember A, B, C is your what? Is your treatment. You have 3 methods of teaching, A, B, and C. So if you want to find the sum of the first treatment, which is A, so because it's columns, and I said the dots go with what? The first dot from the Y there, the first dot is it indicate goes with the rows. The second dot goes with the column. So if I want to find the information of the first, yes, thank you. Thank you. She noticed that I'm taking time. So if I want to find the sum of the first column, I'll write the sum of the first treatment. I'll write YA dot. So this one is the sum. It's also the sum, but only for the first treatment. Do you follow, guys?
No, sir, can you please repeat?
Do you understand this one, the leader? The one where I said y dot dot the 8 part, this one?
Yes.
Yeah, thank you. So here, I want to find the sum for the first treatment, which is A. So I cannot say y dot dot here because my focus is on what? My focus is on a specific treatment, which is what? On a specific treatment, which is A. My focus is on this one, leader. And then if you can check your information, it's captured row column wise, is going down. So it means our focus now is what? Is the J1. So where, because it's columns, where you're supposed to put the second dot, you have to put what? The A. So why A dot? Why the other one is a dot? Because it's not active. We're not focusing on what? You are not focusing on the row, on the what? On the row wise. So this is, let me go back. This is equivalent to Y I J, the summation. This y dot dot is equivalent to summation of y I j. So if you can check leadership, we're going down. So our focus is on what? Our focus is on the j. So that's why we're saying y dot a. The second one will be y dot b. The third one will be y dot c. We are guided by what? How the table is structured. So if you can check the table, what is going what is column wise. That's why we're writing this. But if now I can change the table, things won't be what? Won't be the same. For example, now let me write the table in a different format. A, B, C. Uh, 1, 7, 2, 3, 9, 7, 2, 2, 2. There's a person who asked me a question now. What am I supposed to write here? What am I supposed to write here? Why what? I want to find the sum of the first treatment. What am I supposed to write?
Y A
By
dot.
a dot.
Y A dot. Because now the table is what? Is row wise. So do you understand, leader? The one who said, there was a leader who said, I don't understand. Do you understand now? They are saying now because I changed the table, this now will become what? Y A dot. Y B dot. Because now is what? The way the data is what? The data is captured and so forth. But Y dot dot won't change because you are not focusing on what? On any row or column. So again, the mean now, the mean, how do we find the mean? How do you find the mean of the treatments? How do we find the mean of the treatments? We'll find the, yes, Candy, Matibe?
We take the sum of each treatment and then we divide it by the number of replication.
Thank you very much.
in
Thank you very much, Candy.
We take the number of each
You take the number of the sum of each treatment, the sum of each treatment, and divide by what? By how many replications are we having? Remember, I said we'll deal with the first two principles. Randomization. We assume now when we are given the information like this, a randomization was applied. As long we have more than one value from each and every treatment, we assume what? We know that replication was what? Was applied. How many replications do we have from this experiment? How many replications? Can someone tell me how many replications do we have from this experiment? There are. Memory is saying 3. Do you agree? Are we having 9 replications or we are having 3 replications?
We have
Are
9.
we having, there's 3, there's 9. Let's continue. What are the other members saying? We are 147 here. What are the other members saying? Guys, you don't be. You have to be brave, you know? Don't be scared to try. There are people who are saying 7. Someone is saying 8 now. Thank you. It's fine. As I said last week, if we finish the class without saying something, guys, you must feel jealous. So when you count the number of replications, you only focus on one. You can count it using. There's someone who's saying 2 now. The one who said 2 is a mistake. Maybe it's because 2 is next to 3. The person wanted to say 3. Just add 1 leadership. Just say 2 plus 1. Replications we have 3. We have 3 in a sense that you focus on a certain treatment. But thank you, Mabunda, for adding 1. You focus on a certain treatment. So, but there will be a case where you may find that treatments are not, the replications are not equal. For example, suppose we're having only 14. Suppose we're having only 14 students and 3 methods. So obvious, in one of the method, you want to have what? Equal number of students. So that one will be dealt with it in a different manner. So going back to the mean part, Candy said the summation of what? The summation of, to find the mean, she said, is the summation of, you add the sum of the first treatment, you divide by what? You divide by R. R is the number of replications. If the problem is a balanced design, you just go to one of the treatments and get what? And get the what? And get your replications. So, and now the last notation that maybe I can explain is N. N is equal to the number of replications multiplied by the number of treatments. The number of replications multiplied by the number of treatments. And I repeat, this is only applicable provided this experiment is balanced. N equal to RT provided the experiment is balanced. Which part to repeat, leadership? Why are you saying 27, Smanga? Where did you get the 27? You said 9, I agreed, now you are saying 27. Yes, Smanga. Smanga, unmute your mic. I'm not sure if your mic is on. It's a mistake. We forgive you, Mr. Smanga. Your leaders are saying it's a mistake, so we forgive you. So, based on the my explanation so far, any question that you have so far?
Seminar, any clarity when you say it's balanced? What do you mean actually?
It's balanced because, oh, thank you. The experiment is balanced because they are all from when you're checking the treatments, they have equal number of replications. As long as the experiment is having the treatments are assigned to equal number of replications, it means the experiment is balanced. Let's suppose I remove one value. Let me go like this. Let me do this Matebula. Sorry. Can you see it now? Mabuda?
Yes,
Mabunda?
yes. Yeah, Nasbon.
Is the experiment balanced now?
No.
Why?
Because at C we have 2. I mean, like you divide by
At C
2.
we have 2. So at C we have 2. It means when we do when we want to do some calculations, we cannot divide by what? By the same number of replications. So it means when we get to C, we have to divide by what? The 2. So again, now it takes us back to, it means n is not equal to r by t, isn't it? If the experiment is not balanced, n is not equal to r multiplied by t. Because when you multiply r by t, you will say 3 by t, you will get 9. But you're not having 9 values here. So it means that part where I said n is equal to r multiplied by t is only when the experiment is balanced. Yes, Candy?
So I just
Guys,
wanted to ask if the treatments were also 3.
If
The number of treatments.
yes, we have 3. We have A, B, C, right? A, B, C. It means we have 3
Okay.
treatments. In our case, we have 3 treatments. But it's not always the case that if we have the number of treatments should be equal to the number of replications. No. You can have 5 treatments. From each and every treatment, you find that you have 10 replications. Like the example that I was giving, the one for the methods, I said we have 150 students. What will be our replication there? Where we have 150 students and the experiment is balanced. What will be our replications? Right on the charts. We have 3 methods of teaching. We have 150 students. What will be our replication? It's 50, right? Philippos is saying it's time up. Are you attending time series now? Okay,
Yes,
it's
sir.
fine. Those who are not doing time series, you can remain behind if you want to ask something. But I won't add anything that it would disadvantage those who are attending time series. No, sorry, sampling, sorry. Sampling. Let me stop the